Hello, and welcome to another deep dive episode on the Total Space Network. Today, we are taking a look into the future of lunar operations. What would be the architecture? How would we get the energy? How would we land and launch? I'm Mikko, the host of Deep Dive, and joining me today is.
I'm Rich LB, co-host of Becoming Multiplanetary.
And we also have a special guest from the space community, Sabolsk Yaroi. Would you introduce yourself?
Yeah, hi. My name is Szabolcs, as Mikko told the excellent way. And I'm a space nerd since I know about myself. And I'm working also helping with the What About It channel and some other channels as well. So that's about me.
Yeah, thanks. And yeah, we met on the What About It channel, and I think we all are on To the Future channel as well. And yeah, quite a few channels there.
Yeah, it's not many places you can go where you don't see Sabolch's name pop up.
Yeah. Making all those captions to episodes.
Yeah. I try to help. Yeah.
Yeah. All right. So let's start with the basics. How would living and such differ from living on Earth?
Okay. Well, maybe we should start with the basics. What we should know about the moon. What are the biggest differences? The first biggest difference is the gravity. It's only the 1/6 of the Earth's gravity, so everything is lighter and not so heavy. And second big difference is moon doesn't have an atmosphere, and that is that is really crucial. If you want to walk on the moon, don't forget your spacesuit, because otherwise it can be fatal. So and third difference is the moon is tidally locked to Earth, so it is always facing one side to the Earth as it is going around. And one round around Earth is one orbit for the moon is 28 days. So that means moon has 14 days of night and then 14 days of day. So that's a pretty long moon day. So these are the main differences. Yeah.
Yeah, and creating any kind of architecture or structures on moon and designing a base, you gotta take all those different things into account. You have to get the solar panels generating energy all the time, not only in the daytime. Yeah, there's a lot of things to think about.
Yeah, I like to think about it, how it is going to work, as we listed these big differences comparing to the usual space of Earth, usual living space on Earth. That if we are going to build something on the moon, that can be much higher, because the gravity is less, so the structure, the bottom part of the structure doesn't have to bear that much weight, because it is going to be lighter. And the other difference, which also will help us to build high structures, we don't have the atmosphere, and that means we don't have wind. So we don't have to worry about the wind like in Earth when we are building a skyscraper. Then it's a really important factor in the design to calculate how the wind forces are going to move that, and so on. We don't have to worry about on the moon. so we can build really high structures. Yeah.
Yeah, but one thing needs to be very closely checked on those buildings is so that they are airtight and getting the atmosphere we are able to breathe inside.
So here's a thought. What about meteoroid impacts?
Oh wow. Yeah. Yeah, absolutely right. Because of no air, no atmosphere, not even the smallest defense against meteorites. And if we are looking at the numbers, probably the micrometeorites, but we are talking about mostly because bigger ones are rare, luckily.
Well,
But yeah.
you could potentially engineer design around this problem if you think about it. Because when you construct something on the moon, if you make all of the spaces modular rooms, and each modular room has a bulkhead, then if a meteorite was to impact one place, you'd simply seal off the bulkheads, and it would maintain integrity. And because the rooms are modular, it's really easy and quickly reconstructed.
Oh yeah. That's a good idea. It's a good design pattern for lunar habitats.
You know, it's one of those things that if you can mitigate the risk or at least lower the risk by designing around the problem like that, then it's something that's certainly worth looking into when building these or considering to build buildings like this.
Yeah, absolutely. And even on the ISS, I think the structure is like two-sided, or not two-sided, but there's like two walls. So the first wall will take the first impact, and the micrometeorite will travel much slower to the second wall, and usually that's enough to stop the micrometeorites on ISS.
Yeah. And actually, we forgot one another important factor with the moon. We don't have protection against radiations. So that unfortunately that is a very high risk, because we got moon is outer of the Earth's magnetic field, so it is not protected by that. So that way, the background radiation, which is coming from our direction, it is hitting the moon surface always. So for example, for that we need, if we want to build something on the surface on the moon, for example, a hotel, which is going to happen, I'm sure about it. Then on the hotel, you have to have windows for sure, because if you are traveling to the moon, you want to see the lunar surface, the lunar panorama around you, so all the way to the quite close horizon. So, and for that you need window, and if you want a radiation protection window that can stop or decrease the amount of radiation going through that. For example, you can use multi-layer windows with water in between the layers, because water is quite good for radiation protection. And that perhaps also helps a bit with the micrometeorite impacts, because if it's multi-layered, maybe if the meteorite is not that big or not that fast, that one or two layer can remain intact.
Yeah, and if the windows are made from some sort of plastic, especially one that includes quite a bit of hydrogen, those kind of plastics would quite effectively stop some radiation at least.
Yeah. And then as we are arriving to the materials, the building materials, what we are going to use, it is very important to note that we have to use the in situ resource utilization at the maximum level. So basically, we should try to build everything from the local resources. And for that, we checked what is the composition of the moon, what materials we can find, what elements we can find there. And we found, of course, there is a lot of silicon we can use for bricks, for building structures. But we can also use that for glass, of course, making glass. But fortunately, we have a lot of oxygen, which is very good for humans, for any living beings that we know. And there is also quite a bit amount of iron, which is going to be very important,
as well as aluminium.
yeah.
So,
Yeah, absolutely.
Yeah, both are good materials to build structures.
So you were talking about skyscrapers earlier, Sabalch. The idea of these, obviously, your idea of multi-layered windows would really work in such a structure as well, in order to protect radiation, and meteoroid strikes and whatnot. What do you envision as the kind of style that we would build? Like, would you see lunar buildings have a certain aesthetic style, do you think, that evolves from the functionality of the building?
Yeah, that's a very good point, and I think it is absolutely so. So some kind of functions will the buildings will fulfill these functionalities. For example, of course, we will need gates for going out to the surface and coming back from the surface. This kind of 2 gates where you go inside, you evacuate it, and
Airlock?
the other yeah,
The airlock,
exactly. Airlocks, sure. And beside that, the special environment that enables us to build that much that high structures, and the forces is going to be that different. It will, I think, it will create a lunar style of buildings. So one thing is, these buildings could be higher, but also because of the less gravitational forces, I think the bridges which could be built on the moon, those can be also longer, and building can be connected in the high, like a bridge. So I think there will be a special lunar architectural style created. Yeah, I'm sure.
And then to follow on from that as well, do you think that this special lunar architecture might show us things that we can still learn about architecture on Earth? Maybe like that knowledge transfer back the way?
Hopefully. Well, on Earth, architecture has a lot of history. So architects are working for a really long time. But the architecture on the Earth are also evolving quite fast, because of we know now new materials and new methods, and computer aided design also help, and the computer simulations also help us to build such buildings on Earth, which cannot be built in about 20 years, 30 years, or even a later time. Yeah, but I don't only think about building hotels, but this possibility with building high structures on Moon, it enables us to build such functional structures that help us a lot on the Moon. For example, we can build high launch rails on which magnetic trains can accelerate the payload, so it can be put on orbit. So I don't say it has to be very high, but if you imagine, we can build a magnetic rail line on the surface of the moon, of course, and we can accelerate something to the orbital speed of the moon, which is about 1.6 kilometer per second. But if you do that, and there is a hill or some other higher region of the moon on the way, then you have to modify your spacecraft direction. But if you build a structure that goes higher into some 100 meters high, or maybe some kilometers high, and then you release the payload on that high part of the rail, then you don't have to spend as much fuel as otherwise. So that's I think that's also a possibility. I think well, of course, it depends on if we have a proper mountain, a proper hill that you can use to build your magnetic rail line on, which has the proper angle, then of course you don't have to do that. But we are going to have bases on the moon in several spots. There are specific spots we want to have bases near the Shackleton crater at the solar south polar region, and I can imagine that there are going to be some other spots which will be special for some reason. For example, we can mine some minerals or metals there, or something like that. And then you are not going to have a proper mountain or hill at every site. So this can be a widespread solution for many places, I think.
Yeah, I think that will be reality in well, maybe not few decades, but let's say 100 years from now. We will probably be launching something to orbit from the moon quite often. And I have heard plans about the same thing on Earth, but if you do it on Earth, the structure has to be tens of kilometers high, and the speed also has to be much higher, and the building costs would be, yeah, totally mad.
Astronomical.
Yeah. Yeah. Orbital expenses.
Yeah.
Exactly.
Yeah.
Also, we talked about earlier towers which we can build, and towers can have multiple functionalities. One of those is if it's of course we can use the towers for communication. but some people are already talking about putting some Starlink satellites around the moon in different orbits, and then the communication is solved. So well, maybe that is that's a. I'm sure there are going to be communication satellites around the moon, and now they are already. I think there is the Chinese satellite, right, which is communicating.
It's like in the far side of the moon, or like an orbit that it's visible to the far side of the moon and to Earth, so they can communicate with the rover that is on the far side of the moon.
Yeah, but for surface communication, even for mobile networks, building mobile networks on the moon, you can use high towers. And the other important aspect of you can that you can build very very high towers on the moon is you can put solar panels on the top of that, and of course you can adjust the direction of the panels, and then you are going to you can solve supporting energy for the South Polar region, for example, in the craters where there is almost eternal darkness, so sunlight cannot find a way there. You can use these towers for that as well. And I also just read about a concept that they are going to use mirrors and Fresnel lenses to direct the sunlight from a high point where there is sun to all different equipments on the ground, which could be otherwise in the shadow, and that way it can power different vehicles or bases or devices on the ground. And that is also interesting, and we have to calculate in that these towers can be high also.
You know, whilst you were talking about your towers there, Sabolch, it gave me an idea. You were talking about your structures earlier, where it's effectively a mag rail system that can launch things into orbit. What if these towers, the central core of these towers, doubled as vertical mag lifts, because the escape velocity you need is not that high on the moon?
Yeah.
So you could basically the center of the tower is effectively one mag lift. So if you had the gateway passing overhead, you could then shoot the mag lift up and then rendezvous with gateway as like a shuttle bus service.
I don't really see it now how you imagine it. So we have a maglev.
So if effectively your tower, the center of the tower, imagine there's a hole right down the center, and effectively you just have a cargo or some kind of shuttle, and the shuttle is the central hole is effectively like a giant railgun in a way.
Oh, I see.
And the magnets levitate it
down
through the center of the tower to a high enough speed where it can achieve the escape velocity. And then if you time it so when gateway passes overhead, it can literally be like a shuttle bus back and forth.
Yeah.
And the reverse could also be true, where you have a dampening field with the magnetic field, so that when it comes back down and catches it, it reverses so it cushions the landing.
Yeah. And that's
for orbital or achieving orbit. That's not the best way, because it only gives speed like vertically. You will also need horizontal speed to get into the orbit.
But if you build a tower which is not vertical but has a specific angle, and then you are arriving from the proper orbit, and then you can use it to slow down your payload for landing. Yeah, that's also very interesting.
Yeah, so basically just angled towers, and then the top of the tower, that's the angle, is your actual cannon, as it were.
Yeah. It would be something like a space gun or a reverse space gun if you just arrive to there.
Yeah,
that'd
be cool.
Would solar energy be enough for that kind of magnetic rail?
Yeah.
Would we need nuclear energy?
Well, yeah, of course, nuclear energy is always good. So as we could see for the case of Mars, the solar energy is there. It's proven because the rovers are using that, and we could see that how long time they could use it in a very good, a surprisingly long time. So if we look at what was the planned lifetime of the first missions, Spirit, Opportunity, you can see that solar power is very good, but there are concerns with the dust storms, and then because that lowers the decrease of the solar energy arriving to the Martian surface, and that could be a big problem. And for that, the Mars, these kilopower units, which are being built by the NASA, is a good solution. They could provide safe power for quite a long time. So they are good, and they are good for the moon as well. And but on the moon we don't have dust storms. So for sure, what we know that on the moon, the solar power, you can calculate how much solar power you have at a certain point of time on a certain spot on the moon. So because of that 14 days long night, when we don't have the the light of the sun, we are not talking about the two polar regions because they are special in that sense. So when we don't have the solar power, what we can do is that we can install solar power stations, so lots of solar panels around the moon, around the equator, and make a grid that connects these. This is a mega building, of course, but you don't have to use actual cables for connecting those. Actually, because lack of atmosphere, we can use radiation methods to transfer the energy from one spot to the other. So it can be laser, it can be microwave, whatever is the best choice. And then you have a virtual solar power plant, actually, a virtual solar power plant, which produces a predictable amount of energy at any point of time. And if you manage to distribute that energy to other places, and here comes also high towers, which you can use to transmit the energy with the help of laser, for example. And then that is a good solution. But going back to the MagRail solution, the MagRail is using quite a lot of energy in a short time. So for that, it would be nice to have something which collects the solar energy, and then it can use it in a short time, in a higher power density. And if there are some possibilities for that. The batteries, of course, supercapacitors, or something similar. But probably that is needed for that, to have the right level of high enough level for launching.
I think in terms of the initial energy infrastructure, it's a solid start, and then it's about networking that grid out of there to various places where you might need it. To have like charging pads for drones or something like that, for rovers or anything like that. That would be really handy, because if there's if this technology was somehow available for Mars, imagine if Spirit or Opportunity, when the dust storms came, was able to go and sit on a pad and constantly be charged. That would have been they'd have been fine,
Yeah, they could have been saved that way. Absolutely. Yeah.
Yeah, Rich knows all about the rovers because he did the Mega Rover series with Kage.
Yes, the rover series that we just finished recently, and we're moving on to a collaboration with To the Future now. But more on that later on.
Yeah, I've heard about it. Some from Sebastian. Yeah.
In the 7-part series with To the Future, we take a look into humans in space, how it all started and how it might look in the far future. First episode is already out on To the Future channel, so check it out right after this episode. Link is in the description. We had a long chat with Chabolsk, so I decided to release it in 2 parts. Second part will be released about a week from now. And if you want to listen to the whole recording now and cannot wait till next week, we do have the full raw recording available for patrons. So check out our Patreon page at patreon.com/totalspace to become one of these awesome patrons. Anthony Mann, Warhawk, Adrian Moisa, The Angry Astronaut, Howard Walker, Sammy Oscuro, What About It, Chisuan and Sebastian from To the Future, Gio Bagliari, Framrick, Susie R, and Marco Makuch. Thank you very much for your support. Thanks for listening, and don't forget to tune back in next week. I've been Mikko, the host of Deep Dive Fridays.
I've been Rich LB, co-host of Becoming Multiplanetary.
I am Sabolsh from What About It? Shortly.
Thanks for watching. Bye bye.